The new way of collaboration and innovation has speed up product development and cut in R&D cost. The number of sensors and digital systems collecting data from aircraft, railway cars, locomotives, and automobiles is rapidly expanding. Artificial intelligence, machine learning, and other technologies are transforming the basics how the technology works. So, and customers recognizing these possibilities are demanding more customized equipment and intelligent interfaces. So these new components and technologies are also reshaping the way the engineers design and develop a product. They create opportunities that, when used to full potential, can contain research and development costs and substantially speed up the development incorporation of innovation, allowing manufacturers to better adapt to rapidly changing customer demands. So as an introduction, we saw that the digitalization is going to reduce the time to market and also reduce the cost of product. It also fasten or quick incorporation of innovation is possible with this, and also we can quickly adapt rapid changing customer demands or customer needs. Digitalized technologies give space to new trends in the engineering space. So we will see there is 6 trends that is coming up in engineering, especially in new product development and design. So the first one is that there is going two type of engineers. Two type of engineers are coming up. What two types is, one is the in-house engineer and one is the outsourced engineers. So generally all the engineers who sits inside the companies, the biggest challenge facing is finding the engineer with the right mix of engineering skills. And the growing technological sophistication demands deep expertise in narrow scientific fields like artificial intelligence and machine learning, Internet of Things, and other tools. Their complexity also create the need for system engineers and architect. This specialist probably the hardest of engineers that we can find, and have mastered several engineering disciplines and can address a product holistically, understand how various systems interact and support each other. So meanwhile, the information technology tools and artificial intelligence system will taking over certain engineering assignments, primarily the simple designing task. It is estimated that robots have taken over about 25% of the works of the engineers, just as they replace the workers in the production product in factories and change the skill set of the remaining people. So that is this calls for to acquire the right kind of skills we have to outsource the outsource engineers from other companies. So this have given the term of two types of engineers, that is, one is the in-house engineers, other one is the outsource engineers. Though this becomes so predominant that in-house engineers and outsourced engineers. So the second trend is that naturally it opened up engineering ecosystem, and an engineering ecosystem. This ecosystem will have all the outsourced people, in-house people, and all other stakeholders. So the outsourcing was earlier times, the outsourcing was done to reduce cost, that if we outsource something, some design or something, we can reduce the cost, reduce the cost. But now the trend is that we are doing the outsourcing for accessing new skills in areas like artificial intelligence And also we reassign the legacy works, so in-house engineers can focus on new technologies. So this is the open engineering ecosystem, so need to outsource. So earlier times it is solely for cutting the cost. For cutting cost only we used to go to outsource. Now the scenario is totally different. Now we want access new skills like people in artificial intelligence and all, so that we can reassign the legacy works, so that the in-house engineers can focus on new technologies. Then often involves collaborating. This same time it also bring up many challenges, like that if you have to establish the ecosystem or to maintain the ecosystem, the following challenges are there. Because if you are going to collaborate with some startup companies, there will be a lot of cultural clashes with the established company of OEM. And also the difficulty in aligning these two types of engineers, so who is working in-house or those who are the outsource engineering, to properly align them in the work, to make them work together. And then also to maintain control over the design methodologies. We don't have any control over the design methodologies, and lack of standard IT systems. And also we have the problem for cyber security, mitigation of potential for cyber attack, when especially when working with the third parties. That is the second trend. That is, first trend is definitely there is two type of engineers are formed. One is in-house engineers, one is out-house engineers, because we are certain need for skilled manpower. So it is generally we can easily find out from by outsourcing. So definitely the structure in which the company functions, the design or development team function, it become an open engineering ecosystem where in-house engineers and out-house other stakeholders works together and working for a certain output. And the third one is that optimizing designing, so ecosystem in place. So the third is that optimizing design with the product data, because there is more sensors are put in every product, lot of data and information. Even if you take normal, wherever the feedback, the real-time feedback is there, or just feedback is there inside the system, only when there is any problem we can go and access and find out the data. So the actual scenario is that as many sensors are put, so that as many data we can collect, and it will help the maintaining, repairing, and getting the data for the new product development, to improve the product development. There is more capability to analyze data, and new engineering initiative rising from growing pools of data supplied from aircraft and automobiles and railway cars themselves. The manufacturers have had more and more sensors to their products, and as the cost has come down, advanced analytics become available to interpret the data. So Internet of Things data also, that's improvement based on such as Internet of Things data. So even in aviation, where the product data has been used in earlier year by the manufacturers, now we find new implementations. For example, flight optimization equipment is being introduced that could allow flight plans to alter based on the real-time data on weather and traffic, okay, leading to a better fuel usage and fewer delays. And planes are also sharing data more readily with the air traffic controller and other aircraft to improve the safety and traffic management. So in automakers also, the problem has been the fact that the data rarely makes its back to the engineers in automobile field, because vehicle internal error codes are tracked and used by repair shops to diagnose the problem, but often deleted after the car is fixed. So if they were fed into the database, engineers could track frequently, requiring recurring problems can be fixed them in subsequent designs. So the optimizing the design with the product data becomes the third trend. The fourth trend is that the customer-centric product designs. Now, customer-centric product designs, that is that where we have every company is collaborating so intensively with customers, so they take the data and that just comes as a product feedback and also what they want in their next product. So this kind of collaboration is possible with the IT tools, and a lot of informations are coming. And this one, the equipment makers also use simulation equipments, and at the time of production, the product design stage itself, they give a simulator so that the users can feel the product features in the simulator and can give a feedback to the design to the company back, so that the further design improvement can be done at the design stage itself. So manufacturers provide virtual simulators, and also understanding the users habits, looking at that, if the data, how many times they are going to use, how many they wash, and all those kind of things. These whole data can be used to improve the product and coming with new features in the product. And the fifth trend is that the product data management and other IT tools. So you know that product data is the data flow across the company, because the data flow across the company and different departments, so there is proper communication is there, the right information is available at the right time. So this removes all the functional silos between the departments and within the company itself, so that the design cycle is reduced and speed up the development. So the main challenge is that the engineers are reluctant to adopt new IT tools. So that is one of the challenge in terms of product data management system is concerned. And there is some system rigidity. It's not so easy to use, and some and the poor user interface also shows as a reason that they don't like to use the system. So this is the few challenges using the project data management. Otherwise, if you use these systems, it is going to help very much to do the product development in a faster manner. And the sixth trend is that implementing fully agile development. So quick action on data. So whatever the data is available, it is immediately teams are quickly iterate it, test and gather feedback on the product, and they divide the large volume of data, break into smaller tasks and smaller team. Then they can make sprints, so fastly they can do it very fast if they breaking into small tasks and teams. So also the digital content of engineered products grows. Companies will increasingly turn to agile methods, because lot of data, lot of feedbacks, lot of information we gain from different systems. So lot of information is coming in. So this also help us to go for an agile development. So result is the faster product development cycle. So agility is very much required. So this is the six trends that is coming up because of the intervention of IT tools in technology. So information technology tools in engineering. So as a conclusion, we can say that that real-time innovation and realities of budget, that is real-time innovation and realities of budget cutting, that is budget, we can able to reduce the budget, because even if the overall time of the project reduce itself, going to save a lot of thing in the organizational running cost. So real-time innovation is possible. So that is, we already explained that is based on the inputs, the functional inputs, also for the customer inputs, we can improve the product functionality and product designs, we can improve it. So earlier, in a real-time innovation, in earlier times, it used to take around 3 to 4 years to design and develop a car, and that car will have a life for another 7 to 10 years in the market. Suppose the total development and service time is almost 10 years. But if you go for aircraft, it takes for almost 10 years to develop earlier, and it takes almost 40 years, then it again become obsolete. So at present time, it is not acceptable. So this much of product development time is not acceptable. So these new types of IT tools is really helping to foster development. Instead of focusing only on breakthrough technologies and new models, engineers can significantly expand the capabilities of equipments already in the service through incremental upgrades and software downloads and other incorporation of sensors. So because if you take the transportation manufacturers, they can operate more like an Apple or Mac, Microsoft, and sending software updates to improve the performance of security. Regular upgrades, what is the original equipment manufacturers, regular updates and the flexibility that digital systems provide are transforming what original equipment manufacturers can offer to the customers and what the engineers can develop. Tesla, from the inception itself, in their electrical car customers incorporated technology upgrades through simple downloads, and while vehicle at in the garage or parked on a street, you can do any updates like that. You have a new version of operators coming in your system, and you can upgrade at any time, and you can come up with new features. So the pressure to keep technology cutting edge is even more intense for the aircraft and rail equipment manufacturers, whose products are remaining in service for decades. Public transport authorities are beginning to demand faster turnaround on new trains and trams to provide riders the latest comfort and conveniences. And airlines want to distinguish themselves in the market with more customization of their planes and the customer experience through advanced connectivity. So that is the part of the speeding up of the development of the product. Second one is that making sure the cost part of it. The product is, when the technology advances, everybody want to the money also you have to invest more actually. So most manufacturers are forced to look for cutting the cost. So as a result, engineering department are transferring funds for R&D to digital, possible ways to reduce both the cost and time to reach the market with new products. So annually, equipment makers budget more on R&D and engineering, a significant cost of operation. So adopting a data-driven engineering could reduce up to 10% of their budget, with the saving likely to increase when you become more digital and autonomous and electric. So to accomplish this, engineering department will have to change how they work. So they have to adopt to these 6 emerging trends. Thank you.
Please don't forget to subscribe the channel and press the bell button for notification on new videos. Thanks for watching. Wish you great time ahead.